Press the bell icon on the YouTube app and never miss any update from Tech Primers.
Until now, for provisioning any infrastructure resources, we were leveraging the corresponding platforms, be it Kubernetes or AWS. We were leveraging the AWS CLI or the console to provision the infrastructure within AWS. Same with Kubernetes, we were leveraging the Kubernetes configuration to provision these. Terraform is an infrastructure as a code solution using which you can provision any type of infrastructure if you know the Terraform's language. Instead of learning different platform specific languages, you can learn only Terraform, and using Terraform you can provision infrastructure using the HashiCorp configuration language. Terraform uses something called as HCL, which is the HashiCorp configuration language, using which we will be defining our configuration files and we will be able to provision infrastructure using this configuration file. Before looking at the hands-on part, we need to understand the different options which HashiCorp provides for Terraform. The first one is the Terraform CLI, using which we are going to provision all our Terraform resources. So I'm going to show you with Terraform CLI. There are other options like Terraform Cloud and Terraform Enterprise, which we are not going to use it. If you're having a company and you want to host a specific dedicated Terraform instance, then you can go with Terraform Cloud, where you can define all the sets of rules using which you can provision infrastructure within your environment. If you want to deploy the same Terraform Cloud into your own space, then you can go with Terraform Enterprise. So Terraform Cloud is a package which has different securities or authentications and other features which are embedded with the Terraform CLI. And Terraform Enterprise is taking the whole Terraform onto your own infrastructure. We are going to leverage the Terraform CLI. In order to leverage the Terraform CLI, you need to install the CLI in your machine. So since I'm using a Mac, I have installed the Mac specific version using Homebrew. So the version right now which I have installed is 0.14.2. I'm going to use this particular version to create some resources within my AWS infrastructure. If you're using a Windows machine or a Linux machine, there are different steps which are present for downloading the Terraform CLI. This is where you can download the Terraform CLI from. I'll leave this link in the description below so that you can take a look and then use the necessary bundle which you are interested in. Coming to the terminal, I'm going to be creating a folder called as Terraform Primer. Since I'm going to create this whole Terraform as a series, I want to make sure all the different examples which I show are captured in a single repository. So I'm going to create a GitHub repository called Terraform Primer in my GitHub account, and all the subsequent configurations which I make as a part of the new videos will be part of the same repository. I'm going to create a subfolder under the Terraform Primer called as Getting Started with 1. So this will be the folder where I will be having the configuration for this particular video. So I'm inside the folder. Initially I want to create a Terraform project, so I want to just initialize the Terraform project. So using the Terraform CLI, I can just run Terraform init, using which I want to initialize this particular folder. So right now the folder is empty, so I'm not doing anything here. I'm going to open VS Code. I'll be leveraging VS Code for the Terraform demos because VS Code has decent plugins using which you can leverage Terraform and add some code using the auto configuration provided by Terraform. So I've installed the extension called as HashiCorp Terraform, which is provided by HashiCorp. So this will help us in suggesting if there is any configuration if you're creating a Terraform file. So let me go to the folder. So right now there is no Terraform file as such. So I'm going to create my first Terraform file. You can provide any name to the Terraform file. I'm going to call this as getting started.tf. So any file with .tf extension denotes that it's a Terraform file. So I'm going to create a dummy file called getting started.tf, and that's a Terraform file. So this is where all the configurations will go in so that Terraform can understand and create your resources in a infrastructure space. Coming back to the Terraform UI, now that we have the CLI installed, we need to have a way to connect to the AWS infrastructure. So like I mentioned, Terraform is an infrastructure tool for any infrastructure platform. It's not just AWS or Kubernetes. It can support hundreds of different platforms, be it DigitalOcean or Azure or even Google Cloud. So you can use Terraform or the HashiCorp configuration language to provision infrastructure within these platforms as well. So in order to do that, you need to head into a section called as registry. So registries are a way for you to navigate within the Terraform space. So if you look at the registry, there is something called providers and there are something called modules. So let me cover the providers. So providers are the different cloud platforms or the infrastructure using which you are going to access those infrastructure. So if I, let's say, use AWS provider, my Terraform will behave and convert my configuration files into an AWS specific language which AWS can understand. So I'm going to create a configuration file using the HashiCorp configuration language, which can be converted into AWS specific language using this particular provider. The same applies for different cloud providers and different platforms as well. So in this video, I'm going to leverage the AWS as a provider. I'll be using this particular AWS provider here. Now, how should my HCL file or the Terraform file look like? I'll be heading to the document section here. So the documents will have some examples. So see here. So here is an example where we have a HashiCorp configuration language. Let's copy this first few set of lines and I'll tell you what it denotes. Let me paste it here. So the first one denotes that this is a Terraform configuration, and the Terraform CLI will understand looking at this particular block saying this is the Terraform configuration which I need to load as a start. And the second or the nested structure which denotes the required providers. So here I'm just defining my provider as AWS. That denotes the Terraform CLI should be using the AWS provider for connecting and creating these resources. And also I am providing the name or the path of my HashiCorp providers using which this particular provider will be loaded. Now the moment I add this into the configuration, I can now do a Terraform init and then see what happens. Now if you remember earlier when we did the Terraform init, it was just an empty directory and nothing happened. Now if you look at it, I just added one section called as required providers with AWS, and then when I did the Terraform init, it automatically installed some of the providers here. So see that the HashiCorp AWS provider version 3.39.0 has been installed in this particular CLI here. So my CLI downloaded the version whatever was latest, whatever I have defined here, and it just updated my local here. And that's what Terraform init does. So Terraform init's job is to synchronize the required providers if there is a latest version upgraded, if there is a latest version, or synchronize with whatever version you have provided here. So I have just mentioned 3.0 plus, that's why it downloaded the latest version. Now coming back to the UI or the documentation, there are other sections. For example, you can have a provider section where you can give the region and the other configuration details. I can give the region here directly in the configuration file, or I have the AWS CLI installed here where I have configured it as well. Right now I'm going to use the provider section here where I'll be using US East 1. So I'll be showing the same with the US East 1. The next section you can see here is having a VPC. I'm not going to create a VPC here. Instead, I'm going to create an EC2 instance. Right now, my EC2 console is having no EC2 instance with the name Terraform-example. So I'm going to create a new EC2 instance with Terraform-example to show you how you can easily create EC2 instance with Terraform. Now coming to the documentation here, I need to go to EC2 for creating the EC2 instance, because in Terraform you need to make it understand in a specific language, right? So I'm going to go to the EC2 here. So within EC2 there is a section called resources and there are sections called data sources. We need to create some resources, so I'm going to use the resources section to navigate to something called as AWS instance. Since I want to provision a new instance, I can use this AWS instance. And see here there is like huge set of details which are present here. Let me copy and then I'll explain you what each denotes. So here in the data section, so the data section is what provides what type of data which we can reuse in later in this section. So I have the AWS AMI because I want to create an Amazon specific image, which is the Amazon mission image. That's why I'm using the AWS AMI, and I want to use the Ubuntu image. So I've just given the Ubuntu as the name, and I want to filter out a specific image. So that's why I have given a filter here using which I can query the AWS AMI for getting this data about the Ubuntu image for filtering based on the name, this particular name, right? So that specific AMI image will be downloaded and then used as a AWS AMI. We also have other filters which we have mentioned here. There is also a owner mentioned here where we have defined this is the owner specific for the Ubuntu image. So the data will have the AWS AMI, which we can leverage in other parts of the Terraform template. So see here in the line number 30, we are defining something called resource, which is where we say, I want to create an AWS instance, which is going to be a web instance, right? This is the name of the instance. And I want to provide my AMI as data.awsami.ubuntu.id, which is this data. So I want to get the data about the AWS AMI, and I want to get the Ubuntu image ID name, right? So this will return us the AMI name, which we can dynamically retrieve using the data tag. So this is the complicated way in which you can retrieve data from an existing AWS resource and then store it into the data tag inside Terraform. But yeah, it's a good place to start. So that way we understood that how Terraform now works, right? Using this particular section, we are retrieving the AMI name, and that AMI name is injected into the AMI resource section into the EC2 instance here. We are going to leverage the instance type as T3 micro, and we can provide some tags. So here I'm going to provide the tag as Terraform -example. So that way when I filter it out in the UI, I can see only my EC2 instance. So that's all we have, right? So we have everything ready. Now let me go to the terminal and then do a Terraform init this time. Obviously nothing should happen since we already did a Terraform init. It would have synchronized our AWS providers, which are the plugins, which is done here, right? I mean, it's done. Now there is another command called Terraform plan, using which you can reconcile what's going to be executed on the real infrastructure. So Terraform plan is like a dry run using which you can understand what are the different resources which are going to be created. For example, the green ones denote these are going to be created. So see that our AMI image is this particular ID which got retrieved using the data. So literally the whole plan did execute some of the commands and it retrieves some dynamic values, and it is just substituting all these wherever we require. So see that instance type has been substituted, others are all like known after apply. So these are all dynamically selected based on the defaults which are present in the account. So I'm going to use another command called as Terraform apply. So Terraform apply is a command using which we are going to execute this whole Terraform configuration into our environment. So I'm going to use the Terraform apply. This will leverage the AWS CLI to interact, and it also leverages the AWS provider using which it's going to talk to the AWS environment. Now, if you notice, I did not give any credentials for the Terraform file. A lot of times people hard code Terraform credentials into this required Terraform section, but I'm not going to do that. You can also do that here in this provider section. I'm not going to do that. Instead, I already have my AWS CLI which is configured with my account, right? So using the AWS configure command, I have already configured my access key, so I'm not going to do that. So see that meanwhile our instance is getting created, looks like. See that it's getting initialized, and this is what our CLI response. So it's saying that AWS instance.web is getting created, still creating, and then it got completed after 30 seconds, and the name of the resource is whatever, right? So this should be the instance name. See this is the instance ID, right? So whatever instance ID got created here, we could see that here. So yeah, this is matching with the same instance ID. So this is what we created from the Terraform CLI. In order to understand how Terraform works, we need to now go back to the VS Code. So if you see in VS Code, it created a bunch of other new files. So we did not create other files. If you remember, we created only a file called gettingstarted.tf. Now there are two other files. Like one is called the tf state. There are like .terraform folders, there are providers, and there is a log file called HCL, etc. Right? This Terraform state maintains the state of what is happening or what happened when we last ran Terraform, right? So this will maintain the state of what is the current environment's resource structure and their state, using which it does reconcile to a greater extent. So there is a command called Terraform refresh. So let's say what if somebody created a EC2 instance using Terraform, and then they went and deleted that from the console. In that stage, this particular tf state file will get like outdated, because in the tf state it might tell the EC2 instance exists, but what if somebody went and like deleted it, right? For example, let's go and delete the EC2 instance here to show you what I really mean. So let me do a terminate EC2 instance. So this is shutting down my EC2 instance. Now literally my state file got outdated because I have removed the EC2 instance, but here I will be having reference to the EC2 instance which is present and provisioned here. See that this is the AWS instance which was provisioned. Now how do I refresh the state of Terraform with this particular account? There is a command called Terraform refresh, using which you can refresh the state into the local state file. So the local state maintains the state of the AWS infrastructure, whatever we provisioned earlier, and using the Terraform refresh, it synchronizes what's the current state of the resources which are present inside the environment into our local state. That way, when I again do a Terraform apply, or when I again do a Terraform plan, or even if we can do the Terraform apply, right? Because we want to apply the whole configuration. Now, though you did not trigger the Terraform plan and you want to do a Terraform apply, there will be a reconciliation which will be happening in the background, which will be checking the state of what's present inside the Terraform file with what is the current state which is present. So see that now it says that we need to create a new EC2 instance. So that is where it is saying this plus, right? Where it tells us that we need to create an EC2 instance because the state has been like messed up. Right now I'm going to say yes. Since I said yes, this will create a new EC2 instance with the same name, right, but with a different instance ID. So let's refresh this. So see that one more instance is getting created with the same name, but right now it's in the pending state. So it should go to the running state soon. Yeah, it went already into running state. This will again come back to normal after 10 seconds elapsed time, right? I think it's still creating. So yeah, this is complete. Now this is how Terraform maintains the state, and this is how the Terraform architecture looks like. You have a Terraform state which maintains the state of what happened in the AWS infrastructure. Using the Terraform refresh, you can resync the state, and when you do a Terraform apply, it's going to resynchronize your state and then identify what are the changes which you need to do based on the state which it retrieved from the real environment. And also it will tell you whether these are getting added or deleted. And the core component which is going to execute all these are called as Terraform core. So using the Terraform core, it leverages the state to come up with a new state what it needs to create. And using the AWS providers which we configured initially, it will be executing these commands in the AWS infrastructure. Now how do I delete or destroy my EC2 instance? There is a simple command to just do Terraform destroy. Like instead of doing apply and refresh, you can do a Terraform destroy. This can destroy the EC2 instance, whatever you created as a part of the whole Terraform file, or you can remove content from this particular file. So let me go back to this particular file, and if I remove this section, right, which is the resource here, or let me comment this section. If I comment this particular section and if I do an apply, this also is going to remove or destroy my EC2 instance because I'm not doing any resource creation. So what happens underneath is this gets converted into a state and that gets reconciled. So see that right now we are getting the refreshed state. So Terraform goes and then refreshes the state from the AWS infrastructure, and then it identifies the EC2 instance needs to be deleted because it's not present in the Terraform file. It's been commented. So see that AWS infrastructure web will be destroyed. That's what it says. So literally you can leverage the same file to just comment a section of the file to destroy it, or you can run the Terraform destroy command. So I'll not run this. Instead, I'm just going to show you by running the Terraform destroy command. Before that, let me uncomment this so that it can go and destroy. So I'll do a Terraform destroy. This will also go and remove my EC2 instances, whatever I created. So see, it just returned the same with a red mark. So all these are going to be destroyed. Let me say yes, and this should now go and delete my EC2 instances. Yeah, my EC2 instance is getting shut. So this is how you can leverage Terraform to provision infrastructure. If you look at it, we did not do anything within the AWS console. We did not even touch the AWS console to provision any infrastructure. Instead, we leveraged Terraform using the HashiCorp configuration language to delete and create resources within the AWS infrastructure. Obviously, things gets complicated when you want to club or when you have nested resource creation. Terraform intelligently identifies which resource needs to be created before which, because the way we link stuff, it can easily identify which data needs to be created before creating which resource. I hope this will be a good start for you to get started with Terraform along with me so that you can get along with the series and then learn Terraform in a matter of days. If you have any suggestions on any specific topic within the Terraform series, do let me know in the comment section below. As always, if you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.